welcome to another WJEC A level physics question. This time is question 5 from June 2017's PH5 paper. It's on electric fields, and electric fields are nowadays found in Unit 4. So in this question we've got an electron is located between the plates of a charged capacitor, and we've got to show that the acceleration experienced by the electron is 7.5 times 10 to the 17 meters per second squared. You can do this in one go if you want, but let's show all the different steps so that we can get to the right answer, especially because it's a show type question, so you've got to make your workings clear. So the first thing we can do is calculate a value for the electric field strength E between the plates using the relationship E is V over D. So V is 1.8 kilovolts, don't forget to convert the units. D is 0.42 millimeters, again don't forget to convert the units. So putting those into the calculator, we find that the electric field strength is about 4.3 times 10 to the 6. And volts per meter or newtons per coulomb. This equation tends to lend itself better to volts per meter. Next we can calculate the force on the electron by using the electric field strength multiplied by the charge. So we've got 4.3 times 10 to the 6 times the electron charge of 1.6 times 10 to the minus 19 coulombs. That gives us 6.9 times 10 to the minus 13. And it's a force, so it's newtons. And finally, acceleration is force or resultant force over mass. So we got the 6.9 times 10 to the minus 13 over the mass of the electron, 9.11 times 10 to the minus 31 kilograms. Now if we put those into the calculator, we get 7.53 times 10 to the 17 meters per second squared, which is what we had to show. Next we're told that the electron starts halfway between the plates, and we've got to use the acceleration of 7.5 times 10 to the 17 meters per second squared to calculate the time the electron takes to travel to the upper plate of the capacitor. This is basically a Suvat equation. We're going to be taken upwards as positive, and let's have a look at what we've got. We're not interested at the moment in the final velocity. Initial velocity is 0. Distance is what we're trying to find. Acceleration 7.5 times 10 to the 17, and time, so it's the time that we're trying to find. The distance is actually half of the separation between the plates because the electron starts midway, so we've got 0.21 millimeters. We're going to use the equation that hasn't got V in, so we're going to use x equals ut plus a half at squared. The u bit is 0, so x is a half at squared, and t will be the square root of 2x over a. So let's put those figures in. 2 times 0.21 millimeters, again don't forget to convert the millimeters to meters, over that acceleration of 7.5 times 10 to the 17. And I'm going to use here the exact answer from the previous part of the question. Putting those into the calculator, we get 2.4 times 10 to the minus 11. That's in seconds. Hence we've got to calculate the speed of the electron when it strikes the upper plate, so this time we might as well use V equals u plus at. The u bit is 0, so V is at. So we have the 7.5 times 10 to the 17 times the 2.4 times 10 to the minus 11. And that will give us 1.8 times 10 to the 7 meters per second. Next we've got to show that the speed of the electron corresponds to kinetic energy of 0.9 kilo electron volts. Well, kinetic energy is half mv squared. So it's half times the mass of 9.11 times 10 to the minus 31 times the 1.8 times 10 to the 7 squared. That gives us Excuse me a second, hit the wrong button. 1.44 times 10 to the minus 16 joules. And to convert joules into electron volts, we're going to divide by the electron charge of 1.6 times 10 to the minus 19, and that will give us the kinetic energy is exactly 900 electron volts if you haven't used any rounding throughout the calculations. For the final part of the question, we've got to explain briefly another method of obtaining this answer that the kinetic energy is 0.9 kilo electron volts. Well, if we go back to the original diagram, the PD between the plates was 1.8 kilovolts and the electron started midway. So therefore the electron starts at a potential of 0.9 kilovolts. So putting that down, and it moves to 1.8 kilovolts. So that means that the potential difference that the electron moves through is 0.9 kilovolts. And from the definition of the electron volt, where the electron volt is the amount of work done or energy transferred when an electron moves through PD of 1 volt, it means that the work done on the electron here is 0.9 kilo electron volts. And that's equal to the gain of kinetic energy. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.